Hello, and welcome back to the Maths Behind the Economics YouTube channel. This is the first video in the Logarithms for Economics series. In this video, which is the introduction to logarithms, we're going to discuss what logarithms are. First, we will look into the intimate connection between logarithms and exponents. Then we'll talk about what terminology is involved with logarithms. And as always, I'm going to show you plenty of examples. Let us get going. First of all, I would like us to revise exponents. From the exponent series, we know that 3 squared, or 3 times 3, is equal to 9. We also know that 2 cubed is equal to 8. We know that 10 to the 4 is going to be equal to 10,000, because that's what we get when we multiply 10 together 4 times. So the general case is we got some base, we raise that to some power or exponent, and then we're going to get some kind of answer to this calculation. Now, how do we find the base? When we want to find the base, we just take the root. So, for example, the square root of 9 is equal to 3. I know that the cube root of 8 is equal to 2. The fourth root of 10,000 is going to be equal to 10. So, in general, the pth root of a is going to give me back the base. This is all nice and lovely. I hope that you remember this from the video in the exponent series where we discussed the roots, so I will link it for you if you don't remember. But what happens if we want to find the exponent? Well, that's when we can call on the logarithms. So for example, the logarithm base 3, 9 is going to be equal to 2. The logarithm base 2, 8 is going to be equal to 3. Logarithm base 10, 10,000 is going to be equal to 4. And in general, logarithm base BA is going to be equal to the power. So the basic idea of the logarithm is that the logarithm will help us find the power, the exponent. You can think about it as the power or exponent that we need to raise some base to get to the answer. So for example, in the case of log base 3, 9, you can think about it, what power do I need to raise 3 so that the answer will be 9? In the case of log base 2, 8, you can think about it, what power or exponents do I need to raise 2 so that the answer will be 8? And in the final example, what power do I need to raise 10 so that the answer will be 10,000? Now let us make a bit more space and look at the former definition. Now here is the nicely typed up version of the definition. So if b to the p is equal to a, then log base BA is equal to P. So log base BA is the power or exponent to which B has to be raised to get A. Again, what power should I raise B to so that I get A? So if you remember this sentence, what power should I raise B to get A? Hopefully you'll find the concept of logs a little bit easier to grasp. Now let us look at the terminology. I've already used the base, so when I say base, I mean the base of the log here as well, and this is going to be the number in the subscript. So for example, in log base 3, 9, 3 is the base, in log base 2, 8, 2 is the base, and in log base 10, 10 is the base. Generally, it's the little number up in the corner after the G. Now, there is another thing called the argument, and this argument is the number itself behind the log sign. So in log base 3, 9, 9 is the argument. In log base 2, 8, 8 is the argument. And in log base 10, 10,000, 10,000 is the argument. In generally, the argument is the capital A, which sometimes I also refer to as the answer, because that was the answer of the exponent calculation. Now that we are all clear on the exact mathematical definition of the logarithm, and as you can see here, logarithms are intimately connected to exponents, because for me to be able to define the logarithm, I need to define the exponent itself. So let's see how it works in practice. Let's look at some examples. I'm going to make a bit more space. So if I know that 3 cubes is equal to 27, how can I rewrite that as a logarithm? Well, that's going to be log base 3, 27 being equal to 3. Again, remember, what exponent do I need to raise base 3 to get the answer of 27? Next question. 5 squared is equal to 25. How can I rewrite this exponential relationship as a logarithm? Well, log base 5, because remember the base is the same in the log and in the exponent. 25 is have to be equal to 2 because 5 squared is equal to 25. Next one, 4 to the negative 2 is equal to 1 over 16 because the negative power is 1 over and 4 squared is 16. Now, how can I rewrite this as a log? Well, the base is going to be 4 because the base is the same in the exponent as it is in the log. 1 over 16 is going to behind the log sign because that's what the answer is of the exponential expression. And what comes after the log is the actual exponent itself. Because remember, the log is the exponent. So log base 4, 1 over 16 is going to be negative 2 because I need to raise 4 to the negative 2 to get 1 over 16. Next question, 8 to the negative 2 third. That's going to be equal to 0.25. How can I rewrite this as a logarithmic expression? Well, the base of the logarithm will be 8 because that's the base of the exponent as well. The number behind the log is going to be 0.25 because that's the answer of the exponential expression. And the answer to the log is going to be the exponent itself, which is negative 2/3. Now that we are a little bit more familiar with how exponents and logarithms are connected, let's try to solve some logarithmic questions. So log base 2 16. What is that equal to? Well, the question is, what power do I need to raise base 2 so that the answer is going to be 16? Well, I know that 2 to the 4 is equal to 16, so that means that log base 2 16 has to be equal to 4. Log base 5 0.04. What is this equal to? Now, first of all, I've got 0.04 here. I don't know what power of 5 that is. So first of all, I need to think about how can I express this as a power of 5. So 0.04 is equal to 4 out of 100, because remember 4 stands at the 100th place. Now I can make this a little bit simpler because 4 and 100 can both be divided by 2. So that's going to give me 2 over 50. But I can still make that simpler because both 2 and 50 can be divided by 2. So that's going to be 1 over 25. Now that looks more like a power of 5. I know that 25 is 5 squared, but I also remember from the exponent series when we talked about the negative exponents, which I'm going to link for you, that this is the same as a negative power, so it's 5 to the negative 2. And this is why you have to know all your exponents before you can work with the logarithms. So I know that 5 to the negative 2 is going to be equal to 0.04. Therefore, and let me rub the question mark out from here, log base 5 0.04 has to be equal to negative 2. Remember, the logarithm itself is the power of the exponential expression. Let us make a bit more space again and then look at 2 more examples. Log base 10 0.001. What is this equal to? Again, 0.001 is just 1 out of 1000 because this one is at the 1000th place. I know that 1000 is 10 cubed, and again, because how negative exponents work, I remember that 1 over 10 to the 3 is the same as 10 to the negative 3. So the question mark can be replaced by negative 3 because 10 to the negative 3 is equal to 0.001 or 1000th. Last question for the video. Log base 3 1 over 9. What is this equal to? Well, 1 over 9 is 1 over 3 squared, which is 3 to the negative 2. So log base 3 1 over 9 is just negative 2. Well, I hope now that you understand logs a little bit better. I hope that you become familiar with the terminology when we talk about the logs and when we talk about the argument. And again, remember that the argument is always the number behind the log sign. Thank you for watching and see you in the next video. Bye!